Hello students, so here we are with the question second of the exercise 3.2 of the chapter pair of linear equations in two variables. So the question second is on comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the lines representing the following pair of linear equations intersect at a point or are parallel or coincident. And the pair of the linear equations have been provided in part A, B and C. Before getting into the question, let us see what does the ratio A1 by A2, B1 by B2 and C1 by C2 denotes, and also what is the concept in finding the pair of the linear equations to be intersect at a point, or how the pair of the linear equations can be found parallel, and what is the condition for the pair of linear equations to be coincident. So, if we consider the standard form of the pair of the linear equations, that is a1x plus b1y plus c1 is equals to 0 and a2x plus b2y plus c2 is equals to 0, then the ratio of coefficient of x in the standard pair of linear equations will be a1 by a2. The coefficients of y ratio will be b1 by b2 and the ratio of the constant of the pair of the linear equation will be c1 by c2. And now we will see the relationship between the three ratios, that is a1 by a2, b1 by b2 and c1 by c2. Now if the ratio a1 by b2 is proportional to the ratio b1 by b2, which is also proportional to the ratio c1 by c2, then such pair of linear equations are said to be coincident. And if the ratio a1 by a2 is equal to, or we can say is proportional to the ratio b1 by b2 but is not proportional to the ratio c1 by c2, then such pair of linear equations are parallel lines. And if the ratio a1 by a2 comes out to be not proportional to the ratio b1 by b2, then such pair of linear equations are intersecting at a point, or we can say those are intersecting lines. So this is a logic which we will use to find the pair of linear equations to be intersect at a point or parallel or coincident for the pair of equations being provided in the question. So now let us come to the A part. In the A part, the linear equations being given are 5x minus 4y plus 8 is equals to 0, 7x plus 6y minus 9 is equals to 0. So if we compare these equations with the standard pair of linear equations, then we can find the ratios a1 by a2, b1 by b2 and the ratio c1 by c2. The pair of linear equations being provided here gives the ratio a1 by a2 equal to 5 by 7. The ratio of b1 by b2 is equals to minus 4 by 6 and the ratio c1 by c2 is equals to minus 8 by 9. Just keep in mind that these ratios should be in their simplified form. What do the simplified form means? That the HCF of the number in the numerator and the number in the denominator should be equal to 1. As 5 by 7 is in its simplified form, minus 4 by 6 is not in its simplified form, as the HCF comes out to be equal to 2. So we will convert this in its simplified form. It will be 2 and 3. So the ratio comes out to be equal to minus 2 by 3, and it is in simplified form c1 by c2 ratio, so it will be written as minus 8 by 9. And as we can see clearly that a1 by a2 is not equal to b1 by b2, what it means is that these pair of linear equations are intersecting lines. Now coming to the B part, and comparing these linear equations with the standard form and finding the ratio A1 by A2, B1 by B2 and the ratio C1 by C2. The ratio A1 by A2 is equals to 9 by 8. B1 by B2 is 3 by 6 and C1 by C2 is 12 by 24. Converting this ratio in the simplified form, it will be 9 by 8, 1 by 2 and 1 by 2. Sorry, it's 18. So it also comes out to be 1 by 2, right? As 9 into 2 is equals to 18. So we will write here 1 by 2. And as A1 by A2 is equals to B1 by B2, which in turn is equal to C1 by C2, so these pair of lines will be coincident. Now coming to the C part and comparing the pair of linear equations being provided with the standard form and finding the ratio A1 by A2, B1 by B2 and the ratio C1 by C2. This ratio comes out to be equal to 6 by 2. This comes out to be equal to minus 3 divided by minus 1. And C1 by C2 comes out to be equal to 10 by 9. Converting them in the simplified form, this will be equal to 3, 3 and 10 by 9. As A1 by A2 is equals to B1 by B2, which in turn is not equal to C1 by C2. So according to the conditions being found, if A1 by A2 is equal to B1 by B2, but which in turn is not equal to C1 by C2, then those pair of linear equations will be parallel lines. So we can say here that these are parallel lines. So this was all about the question second of the exercise 3.2. I hope this question is clear to all of you.